Hello everyone. In this video, we are going to discuss what is function template, then syntax, then how to call function template, then examples. This is part 2, and in part 1 we have discussed this program. In this program we define 3 functions. First is calculate min function. It takes 2 integer numbers and its return type is int. Second is calculate min function. It takes 2 floating type numbers and its return type is float. Third, calculate min function that takes 2 characters as parameters and its return type is char. So if we see these 3 functions, they differ in the aspect of data type only. So can we do this thing that we declare a variable, for example t, say, and when we want to call calculate min function, we passed, like we say we want to find minimum of 2 integer numbers, then that t variables, let us suppose we replace this int, we replace this type with t, let us say variable, and then after that if we want to find minimum of 2 integer numbers, then replace that t with int. And if we want to find minimum of 2 floating type numbers, then replace that t variable with float. Can we do this? So let us discuss this thing. So function templates. First of all, what is function template? Function templates are the generic functions which can handle different data types without the need of writing separate code for each of them. Using function templates, the same code need not to be repeatedly written for different data types, thus reducing a lot of manual effort in development, testing and debugging a program. So in our previous video, we have discussed 2 reasons why we use templates. First is try principle and second is generic programming. So when we use function template, these 2 problems are resolved. How? First is try principle. We don't need to write same code for different data types. So this resolves our first problem. Try principle will not be violated, right? And second is generic programming. Yes, because t is, you can suppose t as a data type. So we write code once and we'll use that code for different data types. So this is generic programming, right? So these 2 problems are resolved with function templates. So first is the syntax for a function template that takes a parameter of single data type. Why single data type? Because function template can take parameter of different data type. This thing we will discuss in our later videos. So first of all, we write template. All the function templates begin with keyword template, which informs the compiler that we are going to define a function template. It is followed by parameter t enclosed in angular brackets, and parameter t must be preceded by keyword, class or type name, which establishes that t is a data type. So you can suppose this t as a variable which store data type. Okay, actually this is a template parameter. So t is the template parameter, you can say, which stores the data type, right? So here it is followed by the function body, right? it is followed by the function body. This t is the data type. This is the return type of this function whose name is func name. This func name is replaced by the function name. Then it takes parameters, like this is a parameter list, and this is followed by the function definition, right? That is same as that of the normal function definition, except that in a place of an explicit data type such as int, the generic data type t is used instead. The type parameter t can be used to specify the type of the arguments to the function, return type, and declare variables within the function. So t, you can say this t is the data type, right? So this can be, this can be data type which we want to get parameters, which we want to receive parameters. It can be data type of parameters, it can be return type, or we can declare some variables within the function body of type this generic type instead t. So now once we have declared and defined a function template, we can call it in another functions or templates such as main function with this code, with this syntax. First of all, we write the name of the function, then in the angular bracket we write data type of what? Data type of what? Of these parameters which we passed to this function. Data type of that, of those parameters. And in this video we are dealing with single data type, so these parameters must be of same data type. Alright, so let us discuss an example. Here the program that we have discussed in our previous videos, it is same as that, but instead of writing different functions for different data types, we have defined a template function, right? So in this program we have defined a function template calculate min that computes the minimum of two values of any data type, right? The statements within the function template calculate min are not defined from those defined in the previous program. Here the minimum of two values of type t is processed using the comparison operator and result is returned. Fine. Instead of writing a particular data type such as int, float, char, we are writing generic type, that is t, and return type is also t, and data type of these parameters a and b is also t. Then same procedure that we have discussed in our previous video, using conditional operator we are calculating the minimum of those two parameters that we have passed, right? So in the main function we are calling this function template. As we have discussed the syntax of calling, first of all we write the name of the function template followed by the data type which these parameters of which data type, right? So these parameters are of type int, so in the angular bracket we are writing data type, that is int, and we are passing two integer numbers, right? So control will shift to this, and this t will be replaced, and occurrences of this t will be replaced by int, so return type will also be int, and these a and b variables are of type int. So same procedure will be repeated. Is 3 is greater than 7? Sorry, here must be less than sign. Okay, here must be less than sign. Let me correct this. Okay, when a is less than b, then it will return a, otherwise it will return b. Is 3 is less than 7? Yes, this is true. So 3 will be returned, and 3 is also integer type, so its return type is also int. Then same procedure will be repeated for float and then for char. So in the theory part you can write, when the compiler encounters function template definition, it cannot compile it, as compiler does not know yet what data type the function will be working with, right? So when the compiler encounters a function called calculate min, and after that parameters, right, then for example calculate min, in our angular bracket we have written int, and then we are passing 3 and 7 to it. So the int data type is substituted for every occurrences of t in the calculate min function template definition, and internally it creates a specific version of calculate min function for type int. Okay, so when an argument of a data type is passed to function name, right, function name, that means you can say function template, the compiler generates a new version of that function for the given data type. So we can understand this with the help of this diagram. So when compiler encounters this function call, it will generate a new version of calculate min function for type int. So it will, you can understand this template function with the help of this. All the occurrences of t will be replaced by int for this function call, and for this function call all the occurrences of t will be replaced by float, and then for this function call all the occurrences of t will be replaced by char. So when an argument of a data type is passed to the function template, you can say function, the compiler generates a new version of function name. So the process of creating a function from a template by substituting actual data types for its parameters is called instantiating the function template, and each instantiated version of the function template is called template function. Alright, so let us run this code in our VS Code. So this thing we have discussed. Now answer of one question that I have left in my last video, that why these template functions are called parameterized parameterized functions, because we are passing a function we are passing data type to this template, so that is why these are called parameterized templates, because we are passing data type to this template so that it can replace all the occurrences of t with that data type. So this is a definition of a template function. Then enter 2 integer numbers will be printed on the screen. So first of all we have declared 2 integer type variables x and y. Then enter 2 integer numbers will be printed on the screen. Then we input 2 integer type numbers, right, which will be stored in variables x and y, which are of type integer. Then minimum of integer number is this, and then here we call this function template, right, here we are calling this function template. Also you can skip, sorry I forgot to tell you, we can skip the data type which we have written in an angular bracket, because compiler automatically predicts that because x and y are of type integer, and in our previous example 3 and 7 are of type integer, so compiler automatically understand that these we want to find minimum of two integer numbers, so it automatically predict that these are two integer numbers. So we don't need to write explicitly that we want to find minimum of two integer number. It automatically understand. So here these x and y are of type integers, right? So we don't need to write integer in a angular bracket, so we can directly call this template function. So the control will shift to this template function, and a new version of this function will be created for this int type, right? So this thing we have discussed with the help of an diagram. So it will return let us say we entered 3 and 7, right? So 3 will be returned by this function, then this be replaced by this 3, and then minimum of integer value is equals to 3 will be printed on the output screen. Then this is a new line character. Then we are declaring two variables of type float, then enter two floating point numbers will be printed on the screen. Then we input two numbers of type float. First number will be stored in variable p, and second number will be stored in variable q. Then minimum of floating values is equals to then this function call. So first of all control will be shift to that function. A new version of function will be created of type float, because p and q are of type float, so a new version of function will be created. Then let us suppose we entered 3.1 and 4.4, so obviously 3.1 will be returned and it will be printed on the screen. So similarly in a case of characters, so let us run this code. Yeah, I don't select anything, so let us run. Okay, so enter two integer numbers, so let us say 3 and 7. Okay, so minimum of integer values is equals to 3, that is correct. Now 3.1 and 4.4, minimum of floating values is equals to 3.1, so yes, this works fine. Now characters, let us say f and s. Okay, so minimum of c1 and c2 is equals to f, because it compare according to their ASCII codes, and ASCII code of f is 102 and s is 115. So 102 is less than 115, so it returns f, because return type is char, and if return type is int, then it will return 102, because ASCII code of f is 102. So thank you for watching this presentation.